In this video, we're going to look at solving triangles that aren't right triangles. We can still use the techniques that we learned in previous chapters, the sine, cosine, tangents, and the other trig functions, and apply those to oblique triangles, which are non-right triangles. In this video, we're going to be focusing on the law of sines. There's also a law of cosines. I want to start by going to this trig identities reference that we've got, and you'll notice that you've got both laws over here on the right-hand side. So whatever reference you're using, go ahead and identify where you've got those rules written down so you can refer back to them. I want to start, though, by doing an overview of the techniques that we have so far. So if I grab my pen here, we already have a few techniques. One of them is the fact that the sum of the angles in any triangle adds to 180 degrees. We also have inverse trig functions, and we can apply those, and we've done that to right triangles anyway, to find a missing angle. So these cosine inverse and sine inverse functions that I've got down below, I can write them as giving me an output of an angle measure theta. They do have restrictions though. So cosine inverse is restricted. I think of this as being from the x-axis to the x-axis. We're going to be using degrees for the most part in this section. So from 0 to 180 degrees. So 0 less than or equal to the angles it will return to be a well-defined function. The nice thing is that this means I can get either acute angles, which are less than 90 degrees, smaller than 90, or obtuse angles, which are angles that are bigger than 90 degrees. So, or obtuse, bigger than 90 degrees. For sine inverse is also restricted to make it a well-defined function. Its range is restricted from the y-axis to the y-axis. In terms of degrees, that's going to be negative 90 to 90. So the angle measures that sine inverse can return are between negative 90, so this would be theta, less than or equal to 90 degrees, which means that the only type of angle that sine inverse could ever give me is something less than 90 degrees. These are acute angles only. And that's going to become important as we look at the law of sines. Next, we want to talk about correctly labeling a triangle. And we've done a little bit of this, so I do want to go ahead and go through a review. So when we label the sides of a triangle, we use lowercase letters A, B, and C. When we label the angles, we're going to go ahead and use an angle opposite to correspond with its uppercase letter. So the angle opposite side A is uppercase A, angle opposite C is uppercase C, and then opposite B is uppercase B. It's actually a second way that we can label those angles. So A, B, C, the sides stay the same. And we can label those angle measures instead with their synonymous Greek letters. So A is going to match to angle alpha, B is going to match to angle beta, and C is going to match to angle gamma. So you'll see both of these labelings. Let's go ahead and look at some examples. Here in number 3, we're going to work on constructing the triangle, just drawing it, labeling it, and then we're going to decide what kind of a relationship there is between the sides and the angles. After this one, we'll look at actually solving these triangles. So for this triangle, in part A, we're given an angle of 40 degrees. I always start drawing this with one of my angles. So 40 degrees is about like this. So this is going to be angle A, 40 degrees. I'm given angle B, which is 110, so that's going to be an obtuse angle. So we'll go ahead and put that there, 110. Should use a smaller pen for these. And then side B. So 110 is B. Side B is 12. This guy right here is angle A, so opposite is going to be side A. And I'm not given angle C or side C. So the values that I was given, if I go through and circle these, I was given angle A, I was given side B, and angle B. So if I were to look at these in an adjacent order, I can go from an angle to an angle to a side. So this is angle, angle, side. Part B. So in part B, we're given an angle of 50 degrees. I'm going to start with that labeling. So an angle of 50, so a little more than 45. Okay, so this is B, 50 degrees. And then we're given A and B. B is going to be opposite. So B is going to be over here, wherever that happens to live. So B is 49. A can be either of those two lengths, it doesn't matter. So I'm going to go ahead and label it here, and we'll say that side A is right here at 108. Okay, so obviously not drawn to scale. So what we're given here, if we look at the ordering, is a side followed by a side followed by an angle. So we can label this a side angle or angle side. Whoops, angle side. Okay, so angle side, I should probably not say in my video, but because it is the A word, it's a really great way to remember that this case is the only time that you get two possible triangles. So we can end up with a couple of different possible triangles with some given information. The pieces that are missing in this triangle are, let's see, opposite A, we're missing angle A. And again, we're missing angle C and side C. Okay, let's take a look at part C. So part C, 107 degrees, that's an obtuse angle, more than 90. So something like this. Okay, so angle A is 107. Side A is going to be opposite. So let me just draw this in. I'm just guessing, right? So side A is 35, and side B could be either of the two sides that make up angle A. It doesn't matter where you put it. I'm going to go ahead and put it, I don't know, here. So B is 17. So we are given a side, then the next side, and then the next angle. So this again is side angle, or the A word, angle side. So I know that it's got two possible, that should be a triangle, two possible triangles. We are missing, again, side C. So side C and angle C, and we're also missing angle B. Last but not least, part D. Okay, so 43.1, so about 45 degrees. I'm just going to draw this guy in. It's in green, I guess. So this is A, 43.1. And then I have A and B. So A is opposite angle A. So this is 187.5. B could be either of these two sides. I'm going to put it here. It doesn't matter. 241.5. And again, if I look at my labeling, I have an angle followed by a side, followed by a side. So this is again, angle side. Good way to remember that this gives me two possible triangles. And you'll see exactly what I mean by that as we start to work through some examples. Let's go ahead and introduce the law of sines. So the law of sines is a couple of ratios, and the ratios will always give you the same value. If you want to see the derivation, you can go ahead and look it up either in your textbook or online. So for the law of sines, I'm still using a triangle labeled in the same way. So I've got capital letters for A, B, and C, and then lowercase letters for the sides. So this would be side C, side A, and side B. The law of sines reads this way. So it says the sine of angle A over side A, that ratio is the same as the ratio of the sine of angle B over side B, which is the same as the ratio of the sine of angle C over side C. This works for our two cases of angle side angle and side angle. So this gives you one possible triangle. This one we've got to work for a little bit more. This gives us two possible triangles. Let's go ahead and work on this first one. So this first one, I've got two angles. So I'm guessing it's going to be my angle side angle case. Let's go ahead and draw up a triangle. I'm going to start with one of my angles here. So about 40 degrees. So A is 40. B is 110. So B, angle B is 110, and then side B is 12. So as we work through this one, I can go ahead and start by finding these missing pieces. I'm going to start with finding angle C. So number 1, angle C. And then you'll see why I can say, because right now it's not one of those 3 cases, right? I don't know if you noticed, but we've got an angle, and a side. Right now it's angle, angle, side, which was not one of our choices, but I can easily find the missing angle. I know that these 3 angles need to add up to 180. So 110 plus 40 plus angle C is 180. So that's 150, right? So that tells me that C must be 30 degrees. So C equals 30. So now I've got that relationship I want. I have angle, side, angle. So this is angle, side, angle, one case, which is great. I can go ahead and just solve for my missing sides. Okay, next, I need to solve for side A. I cannot use the Pythagorean theorem here because it's not a right triangle. So I'm going to go ahead and use the law of sines. So as I'm grabbing the law of sines, I want to use 2 pieces of information that were given to me. So that's going to be angle B and side B. So I know I want to grab in my ratios these. The other piece of information that was given to me is angle A. So I'm going to grab those 2 to create my equation. So step number 2, I have sine A over A. I never use all 3 together. Sine B over B. Let's go ahead and plug in what we know. Sine A, so this is going to be, I'll put it up here. So this is going to be sine A, which is 40, over side A, which I don't have, is equal to sine of 110 over side B, which I do have, over 12. Let's go ahead and cross multiply. So I get A times the sine of 110. Notice how I don't compute yet. I don't want to round until the very end. So continuing to cross multiply, I get 12 times the sine of 40. I'm going to divide both sides by the sine of 110. Sine 110. So parentheses here, that's going to find side A for me. Everything's in degrees. So I'm going to start by going to my mode, making sure I'm in degrees, and I'm not. I'm in radians. So I'm going to arrow over to degrees and hit enter. Let's go ahead and quit here. And then I'm going to do 12 sine of 40. You can also do this with Desmos, divided by the sine of 110. So the sine of 110. And we end up with our first side. So we're going to call that 8 point, let's do 3 decimal places, 8.208. So A is equal to 8.208. So writing my answers down, 8.208, and we also had C, which was 30 degrees. Okay, last but not least, I want to find side C. So to find side C, I always go back to the information that was given to me. I want to use this original information as much as possible. So let's use the B ratio from the law of sines along with the C ratio from the law of sines. Okay, I'm going to do this guy in blue now. Okay, so this is going to be step number 3. I'm going to use the B ratio. So the sine of B is 110, divided by side B, which is 12, is equal to the sine of C, which we found to be 30 degrees, divided by angle C. I'm going to go ahead and cross multiply. I'm going to run out of room here, aren't I? I'm going to cross multiply, and I end up with C times the sine of 110 is equal to 12 times the sine of 30. So that tells me that C is going to be 12 sine 30 divided by sine of 110. So just making sure I did all of that right. It looks great. Okay. It's actually really similar to the one that I have up above. So rather than retyping everything, I'm going to arrow up and grab this, or you can type second followed by entry to grab your last entry. All I need to do is to change this angle measure into 30. And we end, excuse me, we end up with our last side, which is 6.385. So 6.385. 6.385. In the next video, we'll go ahead and finish the other examples.